This is a problem that's meant to prepare you for some of the things you're going to be doing in calculus. I would like you to shade a certain area. My description is that it has to be inside r equals 3, but outside r equals 2 plus 2 cosine theta. Now, it's nice if you can recognize what these shapes are going to be. R equals 3, for example, is a circle of radius 3 centered at the origin. R equals 2 plus 2 cosine theta is going to be a limacon, and since the magnitude of A equals the magnitude of B, it's going to be the type known as a cardioid. First, we're going to graph r equals 3. That will be a circle of radius 3. And on label on the outside r equals 3. Or I could have put in tick marks. The cardioid, r equals 2 plus 2 cosine theta. Remember that the pattern for cosine is 1, 0, negative 1, 0. So in this direction, it's 2 plus 2 times 1. That will be a 4. In this direction, it's 2 plus 2 times 0. That would be a 2. In this direction, facing west, it would be 2 plus 2 times a negative 1. That would be 0. And in this direction, facing south, it would be 2 plus 2 times 0. That would be a 2. When I graph it, I expect to get something that looks like this. Now remember, my instructions were to shade the area that was inside of the circle, but outside of the cardioid. So that would be this area. It would be nice to know what these two intersections happened to be. I know the r coordinate because it's on the circle r equals 3. So all I would really need to know is the angle, what theta is. I can find that by noting that the equations are going to be coincident when they hit the same value of r and theta. That will happen when 3 is equal to 2 plus 2 cosine theta. That will happen when 2 cosine theta is 1, which occurs when cosine of theta is 1/2. Now I remember that cosine of theta is 1/2 at pi over 3 and again at minus pi over 3. So the point of intersection in the first quadrant would be the point 3, my r value, comma, pi over 3. That's going to be common to both the cardioid and to the circle. Only provide me with the interception point if I explicitly ask for it, but this would be how you would shade an area between two graphs.